This is Year 9 Physics Module 2, and this is a module entitled Trampoline Physics, and it's all about the kind of physics you would meet when you're jumping on your trampoline. So this was Lesson 1, and we call Lesson 1 Stretching It Out. And one of the first things you met was, how does bouncing on a trampoline involve physics? Because it doesn't sound very much like something you would do in physics. So you did a little brainstorm and we come up with a few things. We know that there's forces involved. We also know that there's energy changes involved. You know that materials are being stretched. You may also know that how hard you hit the trampoline will affect how high you can bounce. So how high you know that your stability, how stable you are, depends on the way that you hit the trampoline and what part of your body hits the trampoline, so your stability. And one of the last things, which may not be just as obvious, is that you may experience some kind of electrostatic shock. So you may meet electrostatics. So you might meet that whenever you get off the trampoline and you touch someone else, or you touch something which is metal. Sometimes you experience a shock. Right, so the first wee bit is just all about forces and what forces can do. So forces can change, and if you remember from Year 8, forces can change the shape of an object, the size of an object, the speed of an object, and that might be that it just starts it moving or stops it moving, and it can also affect the direction. And so those are 4 effects that forces can have on objects. Right, so the next little part was about changing the shape of an object. And we can classify materials as rigid, plastic or elastic. And rigid materials are things like concrete. Steel would be very rigid. Any kind of stone. Metals, although some metals you can bend or stretch. Plastic materials are those materials which you can stretch then. And plastic materials kind of have 2 groupings, plastic and elastic. And elastic materials are materials which will go back to the original shape whenever you remove the force from them. So we know that it's forces which change the shape of the objects, but it will go back to its original shape if you take the force away. And when that happens, then you have an elastic object. So we'll write down an example of an elastic object. So obviously, an elastic band can be easily stretched and it goes back to its own shape again. A spring, a bouncy ball, and possibly something like a sponge will go back to its shape. Now obviously you can apply more force to it, so much so if you pull it, say for example, that you could actually tear it and then you've changed its shape permanently. Then other things which are stretchy but they don't go back to the original shape would be things like blue tack or plasticine. And maybe other softer materials like that which you can stretch out of shape but they won't go back to the original shape. How does a trampoline force you upwards? So this is all to do with the fact that a trampoline is an elastic material. The material that it's made of, it's an elastic material. So it goes back to its original shape when you remove the force. Now, when you jump onto the trampoline, you push down with a downward force. And that force generally is to do with your weight. So your weight will exert a force on the trampoline, and that will push down on the surface of the skin of the trampoline. What actually happens when you bounce on the trampoline, though, is that the trampoline doesn't really like being disturbed from its original position. And what it does is it pushes back, and we call this a restoring force. So it wants to restore its shape to the way it was originally. And so it pushes back on you. And we say this is an example of something called Newton's second law. So we know of Isaac Newton, and Isaac Newton came up with a whole lot of laws about gravity and things like that. And his second law was that his third law it is actually, Newton's third law, if you exert a force on an object, it will exert an equal but opposite force on you. So there's the equal but opposite force exerted on you by the trampoline because you're exerting a downward force on the trampoline. Right, you did a little experiment stretching a balloon, and you used this setup here. So I'll just scan in a little bit just to remind you about it. You don't have to learn this diagram, but what you might need to know is how to work out the extension of the material. So we didn't actually use a balloon, we used some elastic material that you would make a balloon out of. And we had a bulldog clip here. We'd one at the bottom just to get the weights attached to it. And you measured the original length of it. And then for every bit that it extended by, what we did was we measured the whole length and we took the original length away from it. So if our original length, we'll say, was 5 centimetres, and then we'll say that this whole extension, the whole length here, is now 10 centimetres. Then the extension we know is 10, which is our new length. Take away the original 5, and the extension is 5 centimetres. And that's how we calculate the extension when we do this experiment. So our conclusion to that experiment was, whenever you added more weights here, the more weights that you added, the more this extended by. And so if we just have a look at the next page, the conclusion is when we add more mass to the balloon, the extension increased. Now, we can liken this to the trampoline in that, if we have a look at the diagram of the trampoline again, the more force that we put onto the material of the trampoline, the more it is extended by whenever we jump on it. So it'll extend more, it will be put out of its shape more, and the more force then it will exert upwards to restore it to its original shape. And so therefore the harder we jump, the more force is being exerted on us. So when we jump harder on the trampoline is stretched more, and it exerts a larger restoring force on us. And really the result of that is, of course, we move up higher.